Do you see how this minus 5 is kind of just in the back? That means it's going to go down 5 when we graph it. Alright, so the transformation is that it has been translated 5 units down. The new vertex is, just like it would be for an absolute value, what is associated with x? Nothing. What's on the outside? Negative 5. So when I make my xy chart, I put 0, negative 5 right smack dab in the middle. I surround it with normal numbers because I have no fractions to worry about. And I plug those normal numbers in. So I'll do 1 squared minus 5 is negative 4. I will do 2 squared minus 5, that's 4 minus 5, is negative 1. I will then reflect these numbers up here, trusting that I did it correctly. If you don't trust yourself, plug those numbers in. You'll get the same thing. Plot your new points. So 0, negative 5 is going to be over 0, down 1, 2, 3, 4, 5. Okay, let's do the 1, negative 4, over 1, down 4, the other way as well, and then over 2, down 1. We have a perfect parabola that has simply been moved down 5 units. Let's take a look at part B. Notice on part B, the 4 is associated with the x. Because it is with the x, it's going to move left or right. Because it's a minus 4, it moves to the right 4 units. You remember that from absolute values, hopefully. So the transformations is that it has been translated to the right 4 units. The vertex will be what is with x, the opposite of what you see, a 4. What's being added or subtracted in the back? A 0, just like it would be with absolute values. Make your xy chart. Put 4, 0 in the middle. Now that you have 4, 0 in the middle, surround it with familiar points. These points look pretty different to you, don't they? That's because this is the first time you've moved something left and or right. So let's go ahead and plug in 5 and 6. So we do 5 minus 4 quantity squared. I just plug it into the equation up here. That's pretty much 1 squared, which is just 1. And then I do 6 minus 4, the quantity squared. Well, 6 minus 4 is 2. 2 squared is 4. Then I do the same thing with these. And if you don't trust yourself, you're not sure if you did these right, fix them. Otherwise, get the problem wrong. Your choice. Let's plot them. Over 4 up 0. Alright. Over 5 up 1. Over 6 up 4. Over 3 up 1. And over 2 up 4. Notice the perfect parabola has just moved to the right 4 units. Let's try the got it. Which one of these will move up and down, and which one of these will move left and right? After looking at these, I hope you decide that letter A moves up 3 units. And I hope that you notice letter B, since it's associated with the x and it's a positive, moves left 1 unit. Okay, let's make an xy chart. Or actually, let's find our vertex first. That'll be the best thing to do in both the problems. The vertex in this one, you need to ask yourself what is with x. In other words, like, if it was a parenthesis squared, what would it be? In this case, nothing. What's on the outside? A 3. So 0, 3 is my vertex. Whereas on this one, my vertex is opposite of what is associated with x, negative 1, and then what's on the outside? 0. So we'll make our xy chart on both of them. Okay, let's put our vertex right smack dab in the middle on both of them. And let's surround them with numbers. A little smaller than 0 is negative 1 and negative 2, and a little bit bigger is 1 and 2. Do the same thing over here. A little bit smaller is negative 2 and negative 3, and a little bit bigger is 0 and 1. Let's plug in our points on part A. Let's plug in the positive ones because they're easier. So this would be 1 squared plus 3 makes 4. this would be 2 squared plus 3, which is really 4 plus 3, makes 7. If you don't trust yourself, plug them back in. You will get 4 and 7 if you plug in -1 and -2. Do I suggest that you do that? Absolutely. I just have my answer key beside me. Let's plug in 0 now into this top equation. So we do 0 plus 1, and then we square. Well, 0 plus 1 is 1, squared is 1. Okay, do the same thing. Add first. 1 plus 1 is 2. 2 squared is 4. If you don't trust yourself, plug in the other ones. You will get 1 and 4 again. Let's graph our points. Over here, we go left 2, up 7. Left 1, up 4. Over 0, up 3. Over 1, up 4. And over 2, up 7. Again, you have a perfectly shaped parabola, the U shape, not a V. You have a U-shaped graph, which is a quadratic, and it has simply been moved up 3 units. Take a look at the one on the left. -1, 0 is left 1, up 0. Over 0, up 1. Over 1, up 1, 2, 3, 4. Left 2, up 1. Left 3, up 4. 1, 2, 3, 4. 1, 2, 3. Again, you have your perfectly shaped parabola, and it has simply been moved to the left 1 unit. Now, if we ever talk about the domain values of a parabola, it's like asking what x's are we allowed to plug in. You can plug in any x. So our domain should always be -infinity to +infinity. And if you're looking at a graph, it's because it always goes to the left and because it always goes to the right. In other words, it's all real numbers. Now the range values of the parabola, that's where we get a little confused. These will either start or end with the y value of the vertex. Okay? It depends if it goes up or down. Let's take a look at problem 3. For y equals 3 times the quantity x minus 4 squared minus 2, what's the vertex, the axis of symmetry, the min and the max, and the domain and the range? Wow, there's a lot happening. Let's start easy. We have the vertex is number 1. The vertex is, why don't you try it? It should be a +4 and a -2 because it's opposite of what you see. Let's talk about the axis of symmetry, number 2. The axis of symmetry is always x equals that value right there. So x equals 4 in our problem. Number 3, is it a minimum or a maximum? Okay. Take a look at the number out front. The 3 is positive. The outside 3 is positive. You know what that means is that it opens up. Now if you're like me, you're a visual learner. There is a parabola opening up, right? Now if it opens up, what do you think? Should I have a min or a max? In other words, what's that point right there? That point right there is a minimum. So it has a minimum. That minimum value is the y value of the vertex. Y equals -2. You really should pause the video and write that down. The minimum value is the y value of the vertex. Next, we have to find the domain. Here's the easy thing. That's number 4. The domain is all real numbers. In other words, -infinity to +infinity. Because it goes on forever. The range, on the other hand, since it opens up, has a +infinity. Now, what is the lowest value? It starts at -2 and it goes up forever. Let's try got it number 3 using the exact same, just kind of reference above. You might want to try it on your own. First of all, what is the vertex of this equation? You should be saying -1, +4. Number 2, what is the axis of symmetry? X equals -1. from the x value in your vertex. Number 3. The outside number is negative. Because this outside number 2 is negative, that means it opens down. If you're a visual learner like I am, draw a parabola that opens down. So here's your vertex. Is that a minimum or a maximum? Since it's on the top, it's a maximum. The maximum is y equals this value right here, 4. In other words, it never goes higher than 4. The domain should be easy to you. Negative infinity to positive infinity, because it goes on forever, to the left and the right. The range, this time, since it opens down, it has a negative infinity, and it goes up to 4. So when it opens down, it has a negative infinity. When it opens up, it has a positive infinity.